You're mistaken if you think diamond is the hardest material on Earth. Thanks to remarkable technological advancements, scientists have created artificial supermaterials with hardness far surpassing that of diamonds. Carbon is one of the most remarkable elements in nature, possessing unique chemical and physical properties unlike any other element. With only 6 protons in its nucleus, carbon is the lightest element capable of forming complex chemical bonds. All known forms of life are based on the element carbon, because carbon atoms have the ability to form chemical bonds with up to 4 other atoms simultaneously. Under high pressure, carbon atoms can also bond together to form a stable crystalline lattice structure. When conditions are right, carbon atoms can also combine to form an extremely stable and super-hard structure called diamond. Although diamonds are famously the hardest material in the world, in reality, there are 6 other materials that surpass even diamonds. Of course, diamond remains one of the hardest natural materials in the world, but comparing it to these materials is no easy task. Explore the world. The silk of Darwin's bark spider is considered the toughest biological material ever discovered by humans to date. They are even 10 times stronger than Kevlar, the material currently used to make bulletproof vests. The 9th element is silicon carbide, a hard compound. It typically exists in powder or crystal form, with a hardness just slightly less than that of diamond. The brown silicon particles have been mass-produced since 1893. Silicon and carbon belong to the same group of elements and can form this type of hard material under high pressure. But due to the relatively low temperature, this process is carried out through the sintering method. These materials are not only suitable for applications requiring high hardness, such as brake pads or clutch components, armor plating, tank armor, while also possessing superior semiconductor properties. Therefore, they also play a significant role in the production of electronic components. 8. Spherical nanoparticles or rod-shaped nanoparticles. These self-assembling nanodion particles are the hardest artificial material ever created by humans. They could lead to the development of 3D printable body armor. 7. Diamond. As mentioned, this is the hardest natural material in the world with unbeatable fire resistance. However, the hardness of a diamond depends on its formation conditions. The diamond achieves its highest hardness when it undergoes only a single formation stage. Other diamonds, having formed through multiple stages, develop layered growth patterns, which reduces their hardness. 6. Boronite wood. This material is formed from volcanic eruptions, featuring the unique hexagonal structure of boron nitride. Thus, it was named wood-ree boronitride, and theoretically, this material is 18% harder than diamond. However, in reality, humans still haven't been able to gather enough of this material to verify that hypothesis. This material has an atomic structure bonded in a cubic lattice network, similar to the atomic structure in cubic boron nitride and diamond. However, the difference lies in the fact that the atoms in this material bond with each other at different angles. At the same pressure level within the diamond's tolerance limit, the bonds within its structure will react uniformly. However, wood-ree boronite becomes nearly 80% harder under significant pressure, making the fabrication of this material quite complex. Diamond is a crystal of the cubic system, while lonsdaleite belongs to the hexagonal crystal system. Despite having a composition similar to diamond, this material can be up to 58% harder. Therefore, lonsdaleite is also known as hexagonal diamond, a carbon allotrope with a hexagonal crystal lattice structure. This material is formed when meteorites containing coal collide with Earth. The simulation results indicate that lonsdaleite could be up to 58% harder than diamond. However, scientists have yet to verify this in practice due to the rarity of this material. Dyneema. Dyneema is a type of thermoplastic resin belonging to the polyethylene polymer group, with an exceptionally high molecular weight. Most molecules we know have a mass of only a few thousand atomic units, but ultra-high molecular weight polyethylene molecules are extremely long, with a single molecule's mass reaching tens of millions of atomic units. With such long molecular chains, the interactions between molecules will be significantly enhanced. In fact, this is the most impact-resistant material among all known thermoplastics, while also being recognized as the strongest fiber material in the world. Superior to all existing ties and cords on the market, this product is not only lighter than water but also boasts impressive bulletproof capabilities. Therefore, this material is used in the production of superconductors, bulletproof armor, as well as protective structures for cars, aircraft, and many other fields. 3. Metallic glass. It may sound a bit strange, but in reality, this material possesses properties of both glass and metal. Ordinary metal atoms arrange in an orderly manner, forming a crystalline structure. In contrast, the atoms of metallic glass are in an amorphous state, with a structure similar to that of a liquid or ordinary glass. In crystalline alloys, atoms arrange themselves in regions called crystal grains, and the boundaries between these grains are the material's weak points. However, metallic glass has a superior advantage because it lacks such boundaries, making it the strongest material on Earth today. When you strike a crystalline metal with a hammer, the metal's surface will dent because the crystal grains are subjected to force and shift along their boundaries. However, they quickly return to their original state as if unaffected. The reason is that they lack a crystalline structure, allowing them to be easily bent into various shapes. Additionally, their structure is similar to that of liquids, meaning they melt more easily at lower temperatures compared to other materials and can be molded as easily as plastic. Taking the second spot is Baki paper. This nanomaterial is made from carbon molecules in a tubular form, with a thickness of just 1/50,000th that of a human hair. Baki paper is 500 times harder than steel but 10 times lighter. The Baki paper looks like the carbon paper used for old-fashioned typewriters, but it's many times harder than an equivalent mass of steel. Baki paper also has good thermal conductivity and low optical reflectivity. Thanks to its unique properties, Baki paper promises to become a new material for manufacturing electrical devices, transportation vehicles, and even has potential applications in the aerospace industry. And finally, the hardest material on Earth is graphene. It is a single-atom thick layer of carbon, 200 times stronger than steel but 6 times lighter. Additionally, it conducts heat and electricity efficiently, is nearly transparent, and extremely lightweight. To puncture a thin layer of graphene like food wrap, you need a force equivalent to the pressure of an elephant balancing on the tip of a pencil. Its durability is achieved through 2 main factors. First, each carbon atom is surrounded by 6 other atoms in a highly stable honeycomb lattice, with the atoms tightly held in place by extremely strong covalent bonds. Second, its extremely simple 2-dimensional structure leaves little room for potential errors to arise in the network. Graphene can fill electron gaps with neighboring electrons almost instantaneously, indicating its ability to transfer a large amount of charge in an extremely short time. Thank you, everyone, for watching this interesting video.